I think we'll wait for about 2 to 3 minutes for people to join. അത് കഴിഞ്ഞ് we will, as a matter of principle, start on time, and in future we will start exactly on time and we'll try to close it exactly on time as well. Okay. Uh, Good afternoon, good evening. We have just waited for 5 minutes for people to join, being in the evening at 7 o'clock. Uh, Now, as far as possible, from next meeting onwards, we'll start exactly at the appointed time and also try to close exactly at the uh, end of the time slot that we have actually taken. Number two, this year, for some reason, especially due to COVID dislocations, we could not arrange some of the proposed talks for the year and also other activities of consultant network of IEEE Kerala section. And maybe this is actually the first lecture series, the first lecture that we are going to have. But we are lucky that one of our own member and well-known speaker on technical subjects, who is also a speaker in the International IEEE Consultant Network, the most important one being the Consultant Network of USA. In fact, only a few days back, he had a talk in a consultant network based in Seattle. Very successful one with a very vibrant discussion following. It is none other than engineer Ajit Gobi, who is actually the vice chair of Power and Energy Society of Kerala section, as well as career-wise, he is currently the joint chief technical manager of Agency for Non-Conventional Energy and Rural Technology, ANAT. So he's well known in the technical discussion area in Kerala and also within India. And I don't think he needs any further introduction to any of the participants who are now aligned and waiting for today's talk. Straight away, its topic, of course, is projected over there, the importance of solar resource assessment and monitoring in PV power plant performances. In this, as we will find, PV power plants are going to be an important element in the power system of tomorrow. Even now, it is a major share, but that is going to be a dominant share very soon. Therefore, about power plant performances, something which professional bodies like ours should be discussing more often. Other thing is about solar resource, its assessment and monitoring. This is again, solar is one of the resource which is now bypassing or overtaking the wind energy resources. And these two together is a very formidable force currently in taking renewable energy to meaningful heights all over the world. And so I think it will be very interesting and informative for each one of us to listen to Gobi and then indulge in a brief discussion, which will actually be more enlightening than the talk for him as well as for we who are attending. Thank you, and I pass on the forum to Engineer Ajit Gobi, and around 30 minutes is yours. It is up to you. Try to finish as far as possible within this time and allow us to have a meaningful discussion thereafter. Thank you, and Engineer Ajit Gobi.
Thank you, sir. It's a great privilege for me to be here in this IEEE Consultants Network. And thanks again for having me, IEEE. So I think I participated in the initial meeting of the initiation of the IEEE Consultants Network held very recently. And actually, this is a very great initiative chaired by our beloved VKD sir, because we technocrats can speak and discuss and network to get solutions. I myself has been engaged with the different kind of networks, like the International Solar Energy Society, for which I have been a platinum member for the last 10 years. There also an international expert network is there, which we always meet to discuss renewable energy. So of course, a lot of challenges are ahead for us to discuss and find solutions, because that will be always good for the industry. Because I'm also coming from the industry, I could share a lot of ideas to the academic people, to the fellow researchers, the consultants. I myself come from a background of consultancy as well. When I was working with an international consultancy, Parsons Pinkerhoff, named PB, you may be knowing it. It's short named as PB now. Yeah. It has the base in New York, US, and I was responsible for looking after its Indian operations, Indian Asia Pacific operations based out of Bangalore. Couple of years I have been there, very fortunate to be there with dealing with the consultants' work entrusted to Asia Pacific areas. That was my leave time when I was on leave with ANERT for 2 years. So we had international projects in China, near to Shanghai, projects in Portugal, projects in Hong Kong, and India also. We had a lot of projects, around 100 megawatt wind farm in Kutch, Gujarat, and about the first 25 megawatt project of under the Gujarat solar policy. I had the fortune to work in these projects, and so later when I came back to ANERT, I started a consultancy division there, sort of thinking that why can ANERT become a consultant? ANERT itself becoming a consultant, positioning as a consultant. So we could earn around more than 1 crore business for ANERT in a couple of years with that result. So with that intro, I would like to move to my slides. Let me share my slides. I think the screen is visible now. Can anyone confirm?
Yes, yes.
Okay, sir. Thank you, sir. So as rightly pointed out by Vikiri sir, this presentation, actually the same presentation I had presented in Seattle IEEE Consultants Network chapter. Same I'm presenting here. I think I have added some more slides here, more relevant slides. So if you look at solar PV business models, we have a lot of business models evolved or evolving, emerging. Of course, solar rooftop is the major, it's kind of technical model. It can be a technical business model. So solar rooftop power plants are very popular in Kerala because of the scarcity of land. Of course, a lot of projects are coming on the roof, on the ground mounted area. If you look at globally, according to REN 21 report, more than 90% of the projects are ground mounted projects. 627 gigawatt, I remember, 627 gigawatt as per the latest REN 21 report as on 2019. So the latest report of up to 220 will come maybe a couple of days. I think it is simultaneously they are releasing it. So a lot of activities are happening in the ground mounted side. You can see a huge power plants in India as well. The 2,250 power grid plant in Tumkur, Karnataka, 1,000 megawatt plant, the single plant, which is the single site, mega site in Kurnool, Hyderabad, which is 1,000 megawatt one. 2,050 in Rajasthan. So a lot of projects are coming in the utility scale. The first being in that scale was 638 megawatt, I remember, by by Adanis. They installed it in Kumuthi village of near Ramanathapuram, Tamil Nadu. I was fortunate to do the feasibility assessment or kind of resource assessment, the same subject that I am speaking here, for the Ramanathapuram district. Exactly the Kumuthi. When I was with PB, we did this resource assessment because we know that pretty good solar installation is there with the Ramanathapuram area. So Kumuthi we selected for, based on our comparative studies on satellite assessment. Then that data has been transferred to big groups, and so fortunate to see that 638 megawatt came there. Excellently generating power, I understand from my Tamil Nadu friends. And floating, of course, it's the next thing happening. The next thing should happen in Kerala as well, because of our own kind of 40% of water body area and lot of dams around where reservoirs are plenty, where like our public utility itself is owning around 51 dams where you can put floating solar. And solar microgrids, like standalone solar power plants, mostly off-grid plants. We had experience, Anand had experience. Fortunately, I am also head the first solar village electrification project in Kerala, which brought light to around 20,000 homes in 2004, with around 80 crores rupees from Government of India coming up. Out of that, we had experimented around 12 microgrids, like small 100 houses lit up with the solar, a small area with the solar panels, and then later inverted and distributed to that area. So solar microgrid still a very good option for isolated communities. I happened to be in Tanzania a couple of years back, part of my Swedish Academy program, alumni program. So we had a solar wind workshop there in Arusha in Tanzania. I've seen a lot of solar microgrids there, because there you can see, if you travel into the remote areas, you don't have the conventional lines. You need a lot of microgrids. So around more than 1 billion people are without access to electricity, especially in sub-Saharan area and even in Southeast Asia. And agri-PV is another emerging area, which is agri-photovoltaics. Kerala kind of atmosphere, we can think of it, and we have some experiments done in Chittoor area in Palakkad. So utilizing the same area for agriculture is itself a kind of erected structure for PV modules. So a lot of research is record on that area, how the fertility is there, how the plants will grow. So that's it about agri-photovoltaics. And a lot of PV hybrids, PV combined with the DC, PV combined with the RE sources itself. PV combined with the wind is a very attractive combination. Proposed by MNRE itself for the last several years. They have a typical kind of 3 kilowatt wind, 2 kilowatt solar combination of a 5 kilowatt, typical 5 kilowatt solar PV wind hybrid. They call it SWES, solar wind energy system. So a lot of projects are evolving. Even rooftop, if you look at rooftop also, you have a lot of dam top. KCB itself has installed dam top. You can have the rooftops in community buildings, industrial buildings. You have a canal rooftop systems. So a lot of projects are evolving because PV is becoming matured, and PV has already reached grid parity as such. So coming to the data collection, all these projects need data collection in the beginning of the project. During the beginning of the project, you need data of the site. Especially this is required for a project where where if you are going to install a utility scale power plant, because then you have to design the system. Then the next is when you run the power plant, you need to get the data to assess the performance of the system. So these two things you have to do: a preliminary data feasibility study as well as for the O&M of the project. This is a typical simple integrated SCADA system along with a PV plant. You can see a pyranometer here, which measures the global tilted irradiation, GTI. So it will be something like in kilowatt hour per meter square per day, and which will be useful for finding your performance ratio. I'm coming to performance ratio later. And you have a lot of other sensors like ambient temperature sensor and stuff, and a lot of sensors you can put here, even wind measurement you can put up. And then you can have the remote view of your the status, and even the generation. You can have a look at the generation, what is happening here. But it's very common in rooftop systems. You have Android-based your mobile can provide your generation data. But when you look at the utility scale power plant, this is very important. So generally, if you look at data monitoring systems, a pyranometer is very important for solar resource assessment. So, and at the same time, if you want to monitor data, a cell-based solar radiation sensor is very important. When you go for a rooftop-based system, it's rather cheap when you compare with a class 2 kind of pyranometer with the higher quality. So class 2 or better is advisable for higher kilowatt peak systems or utility scale power plants. And there will be integrated temperature sensors as well. And generally, we monitor this data: AC voltage, AC current, output power, energy in kilowatt hour, DC input voltage, DC side temperature, inverter status. And global tilted irradiation is recorded for the performance ratio calculations, module temperature, string voltage current. But these are all the status, general, the basic status that we are measuring. If you look at a typical daily generation graph, this yellow curve is the watt per meter square, the solar installation, and the red one is the kilowatt hour peak, kilowatt hour the generation. So it always follows the previous one, the installation. You can see it. This is just because of our kind of atmosphere. The humidity is much higher. You have a lot of clouds, and there are a lot of ups and downs here. So this is from the 100 kilowatt plant I was fortunately installed part of ANERT's consultancy program, deposit work program, and this is that particular plant of a plant we installed 5-6 years back. The basic 250, when the 250 watt peak modules were the highest capacity modules. Now it has come, the minimum level has come as more than 400 watt peak. And of course, other than the basic integrated embedded systems, you have the IoT-based solar PV monitoring systems, which are wireless in nature. You have all the sensors, your current sensor, voltage sensor, pyranometer, temperature sensor, and if you have wind energy also, you have that kind of sensor. Without wireless network, you are getting this data to the input of the microcontroller, and through a gateway you will be uploading this to the cloud. From there you can view it through your mobile application or wherever it's possible, or your host computer. So this is a typical IoT based. So it will be a wireless network. So this is a new trend. People are not using the wired network, which will have advantages as well as disadvantages. It will be a three-layer IoT structure, like a lower layer of sensors, controllers, and all. You have a middle layer of your protocols, and to your upper layer of your cloud platform, and of course there will be the applications of Adele to see from the Android or from the other Apple phone. Or so there are three layers basically. Basic layer is the sensors level, where if you put more sensors, you will get more data. That is the mantra of it. Why you collect solar data? So of course during the feasibility and as well as during the operation of the plant, we need data. The technology selection can be done, of course, with the data collection, siting, system design. So these three parts we need to do regarding our feasibility study. And performance monitoring, of course, we engineers will be always looking at the performance monitoring or performance of the PV plant to its record commercially as well as for academic research purpose as well. And I was telling about the performance ratio, which is the typical performance ratio is actually the actual generation divided by the simulated generation based on the climatic parameters, or theoretical generation based upon the climatic parameters. It is a so you need actual generation at the same time the simulated generation. The simulated, you can simulate it through the actual climatic data. So that's why the pyranometer data input is very important. POA, GPOA is pyranometer data. It's a global tilted radiation. So it can be, this is the actual kilowatt hour. By PSTs is the total capacity of the power plant. GPOA is kilowatt hour per meter square. The GTI you are getting by either by the your cell-based pyranometer or a thermo pile based pyranometer. GSTs is nothing but the ground level solar insulation, like it is in kilowatt hour per meter square. It is 1000 watt per meter square. So this is constant. So this value is very important. If you look at, if you calculate PR, we all engineers are looking at PR. Even for commercial acceptance, we use PR. So PR is something like for a higher PR plant, for a very good plant, we will get 80 value. So PR is something like without the units. So sometimes it is termed in percentages. But I would like to say that if you want to compare plants internationally, any plants can be compared with that. The quality of the plant, your module quality, your inverter quality, your wiring quality, and your string combiner box quality, all this stuff can be well compared with this kind of a performance ratio. It's a global kind of measure to compare a plant than generation. You cannot go with a generation, you cannot check generation and compare that and tell that this is a good plant, because generation is completely dependent upon your climate. If you have too much of rain in that period or too much of cloud in that month, you won't get that much of PR, that much of generation. So you predicting you are accepting the plan based on your generation alone can guide you into a wrong way. So it is a globally accepted thing is that PR has to be measured. So PR, even though it is rain or cloudy or sunny, your PR will be something like based upon your quality. So PR is very important metrics. In academics also, PR is very important. Performance ratio is very important. So PR is actually defined by IEC 6172, IEC 724, 2017. So every day this has been revised, but the latest is IEC 61724. 2017 defines this equation as PR is equal to sigma ENACI by PSTC, sigma PSTC into GPOI by GSTC. Okay. So there are, I'm not completely going through this. We'll go to the other slides because of the time constraint. We'll discuss it later. So you have a lot of clouds, aerosols, water vapor, and stuff like that you are installation will be affected. So it's very important that you have these factors are very important when you look at your solar installation. That's you know about that. If you look at the solar radiation coming to Earth, you have direct radiation and diffused radiation. Direct radiation is something coming directly from the solar sun, and diffused is something scattered by the molecules and particles, and still managed to get down to the surface of the Earth. I will get to the exact definitions of direct normal radiation. DNI, I was telling about DNI. You cannot install solar thermal power plants in Palakkad. Though Palakkad is the area where we have a very good installation. We have that 2 megawatt plant there. Because you need kind of a higher threshold DNI, about 7,000 or 7 sun peak hours or 7 kilowatt hour per meter square per day. We call it a sun peak hours or peak sun hours. If you have more than 7 DNI, then that area is suitable for your CSP, concentrated solar power plants, not photovoltaic. So that's why Japan, Rajasthan is most suitable area for that. And you have diffused this, as I said, that is the things scattered through clouds and whatever managed to get on the horizontal surface is diffused, DHI. You have global horizontal irradiance is actually the sum of direct normal irradiance and diffused horizontal irradiance can be, you can measure DNI using a pyrolometer. Pyrolometer, you have a thermocouple kind of thing, which will convert heat to electrical signal to measure it. This is a pyrolometer. You can have diffused horizontal radiation where you can measure it, as I already explained, through a shaded pyrolometer. So if you have a tracker kind of thing, the tracker will, continuously this shade will be following the tracker, the sun, to make it shaded always. So this will give you the DHI. And GHI will be the sum of this. So we generally, when you go for solar resource assessment, utilizing various satellite resources, you have a lot of number of satellite resources, like Meteonom is a paid resource, Vaisala, it's a paid resource, NREL, it's not a paid one, PVGIS is free in Africa and Europe, Helioclin, it's free in Africa and Europe. I remember the days when I was as a consultant, we were doing some projects, assessment for a Korean project, actually. They have done the projects without tracking, and they wanted to see that with tracking, what will be the difference? With tracking, what will be the difference? So, so this tracking will add a lot of extra solar radiation to the solar panels, which will increase the yield definitely. So pyrolometer, as I said, DHI will be DNI into cos theta Z plus DHI, sum of DNI and DHI. Of course, there is a component of solar zenith angle, which is theta Z, which is angle between the local zenith at the line of the sight to the sun. And you have a lot of data now. Basically, people as technocrats, as solar enthusiasts, and as technocrats and academicians, we use satellite data a lot because Meteonom kind of data have a precision of 8 square kilometers. Their grid is 8 square kilometers, which is almost good for us to judge. So ground-based, you have the meteorological data from the district, the meteorological people, the Department of Meteorology, but they have limited data because they have a limited arrangement for measuring it. Costly equipment and limited availability of long-term data. Satellite derived data will be always long-term data. It will be 10 years to 20 years data is available, which generally we use to assess situations. Ground-based data collection is actually, I already explained it. Through it can be done through SCADA or can be through other weather stations and all. See, these are some of the data prepared by map prepared by National Institute of Wind Energy. National Institute of Wind Energy, NIO is actually earlier CVET. They are under the Ministry of New and Renewable Energy, the central ministry. They started a resource assessment study, SRRA station. They had stations in Kerala as well. We have a station at Kudalmandam, Palakkad, along with our solar plant. And this is the published maps of DNI, DHI, and GHI. From a typical SRRA station. No, this is very interesting to observe, to learn something about it. You have a lot of equipments here. You have a 6-meter wind mast, ultrasonic wind anemometer. You have a PV panel to power up the instruments. You have rain gauge. You have a solar tower where you have the pyranometer, everything is here. You have a lightning arrestor. And if you look at the solar tower, you have the shaded, you have the shaded pyranometer here. You have the DHI, this is for DHI. You have the pyranometer. This one, the pyranometer, which tracks the sun. You have a pyranometer for measuring the GHI. So the same thing, we installed at the rooftop of our Kudalmandam solar power plant. Kudalmandam, I was fortunate to lead that project from the concept to the commissioning and currently managing the plant. Our beloved BKD also was in the team to check the design when I was designing this plant along with Dr. R.V.G. Menon. So this project is the first IPP project. This is the first IPP project of first solar IPP project of Kerala. And now we are almost into, we are earning revenue from KCB. More than 11 million units have been fed to the KCB. Yeah, around 12 million units to the power to the KCB grid. This is the typical SCADA data coming up. Actually, the screenshot. This is the SRRA station. Actually, the SRRA station is actually having. You have the PV plant here. You can see the PV plant here. This is a rooftop plant. Nothing but a rooftop for. I thought of this idea because based on my experience in Tilda in Raipur. Near Raipur, I had a 2 megawatt plant in Chhattisgarh when I was doing the consultancy. There we struggled a lot to get some power from the utility to have the basic things running. So I thought we will be independent when we installed this plant. So I put a 10 kilowatt plant. We use this same power to do some kind of machine, to run some machines or during our installations. And now we are using complete auxiliary supply from this. Around 15 units per day we need the auxiliary supply, and we have the interior lighting provided by this rooftop plant. So this is the SRRA station. You have the panel powering up the whole station, rain gauge, and you have the lightning arrestor and the ultrasonic anemometer. The instruments, various international calibrated instruments. So this is the data logger of Geonica Spanish on with international quality. So this is a typical generation. You can see how it performs in a typical day from, the whole 24 hours has been, you can see how it starts with the 6, the generation slowly starts, and hourly generation is in the orange color, and you have seen the GHI and the global tilted radiation. So the GHI is measured on GTI, derived it from it. You can see the GHI and GTI follows the same path along with the generation. You can see this according to the global radiation, the generation follows. And coming to the monitoring of the plant, you need a lot of, and at the same time, you can do the assessment using a lot of satellite data. lot of resources are available for solar satellite from the satellite. NASA data is a popular one, but you have around 10 to 14% error for using NASA data. More optimistic data, I would say, based on my last 15-20 years of experience on NASA data. You have NREL data is more accurate, I should say. Meteornom is a very accurate data. It's like, as I mentioned, it's 8 square kilometer precision is there. PVGIS, it's available for Europe and Africa. It's not free for Kerala, India. Solar GIS is also worldwide. And there is a global wind atlas by Denmark Technical University, DTU. You can browse DTU Global Atlas, where you have plenty of data available. And NREL, yeah, I'm not going much into this NREL data. You can go with that. These people are providing a lot of private stations through satellite resources. And to optimize why you need monitoring of the plant? You need to optimize the system performance. There's a need we need the plant's components should run efficiently. So continuous monitoring is very much required for a power plant. There will be O&M team along with any utility scale power plant. It's not needed for a rooftop plant, but you need regular maintenance, I should say. Regular cleaning of PV modules, regular maintenance. Utility is very much needed because you need to clean it, you need to measure your string current, string voltage, observe your weather parameters. And you have to see at the inverter level or at the combiner box level, you have to measure everything. So solar resource assessment and energy analysis is a greater challenge for every consultant. Generally, consultants will be doing this as a first assignment. We are fortunate to get a lot of assignments from international organizations when I was with the PB. We did for around 25 megawatt project in China near Shanghai in Jiangsu province. So we used kind of PVSys software for predicting the data, and after analyzing after the actual site visit and getting the actual data, we compared with the PVSys and just compared, saw that what is exactly the difference of prediction and actual generation. So this is actually a PVSys is a very good tool for a consultant for design and for due diligence. So you have a lot of PV softwares like PVSys, PVSol. SAM is an academic software from NREL, National Renewable Energy Laboratory. RedScreen is another one from Government of Canada. I've been using RedScreen for the last 15 years. RedScreen is a wonderful software, I should say, for the analysis, not for the design. So you can just get all the magic numbers of your NPV, net present value, your IRR, internal rate of return. You can use SAM for your even for your financial analysis. Helioscope is a very good tool for like feasibility assessment. All these tools are design softwares as well, and optimization softwares and analysis softwares. So PVSys is actually it is actually from University of Geneva. They developed it, and in NRT we had a licensed. I have been using a licensed version. You have trial versions available. A lot of academic students know when we guide MTech students and all, they will be using this academic purpose. They will be using trial versions. PVSys has a lot of components for your standalone pumping, DC grid, and you have a very good shading analysis and a 3D modeling for your placing your solar PV module and doing a simulation of your sunrise to the movement of sun can be traced and see that whether shading is there. So typical PVSys screenshot. not going much into that. You will get, this will be the results. You have your generation, your system laws, and your collection laws. All these things will be put up with very good geographical or graphical data. The yellow, the violet color is actually the system, the collection laws, PVRA laws, due to different issues, majorly temperature laws. The major collection laws happening because of the temperature laws, and a lot of other losses also, mismatch kind of losses. System losses will be very less, minimal, because of the temperature and ion losses. And you have this produced energy. And SolarGS is another software we use it for designing. Here, it's interesting thing is that you can have this global tilted radiation and the generation things. Here, you can get the DNI also from this. This software provides your DNI, direct normal irradiation. No other software provides this. You can have the global and diffused horizontal radiation from this. DHI and DNI from the, GHI and DHI, diffused global horizontal from here. And this is DNI. So this only one software provides this information. And PVSol is more, based on my experience, I should say that it's more graphical experience. So you have a lot of visual effects using this, a lot of 3D platforms for analysis. And SAM is actually a good software for your more academic purpose. You can string-wise, you can assess it, do a lot of work, kind of permutations, combinations of changing your module types, changing your array configurations, changing your inverters. So SAM is a very good model, even for financial analysis. This is SAM output. I've done a simulation using SAM. Red screen is actually, I already explained to you. What I found is actually, Red screen is very, very, very good software for getting your environmental impact, GHG analysis. What exactly the total tons of carbon dioxide are replaced in a year. So all these magic numbers you will get from Red screen. So it's an amazing software. They are evolving, and they are making new versions. Mr. Grigory from Red Screen, the actual developer, he's from Canada. He's a friend of my LinkedIn friend, very close. Since I have projected a lot of my projects in Red Screen, so he was very happy that we are using it. So Red Screen, you can get the cash flow as well. No? You can see the cash flow when you are going to break even. So I'll show how your 200 kilowatt plant, a mid rooftop plant, a middle rooftop plant can benefit environmentally from Red Screen. Just an example for you to show. I have limited time now. I will finish within 5 minutes, my allocated time. So this is a 200 kilowatt installed in Jai Hind market in Thrissur Corporation as part of my consultancy, Anode consultancy work. So this is a 340 ton carbon dioxide. You can see GHG reduction is 340 tons per annum. It's equivalent to 62 cars not used for an year. It's equivalent to 780 barrels of crude oil not consumed. It's equivalent to 77 acres of forest absorbing carbon. See how amazing this is? With a simple 200 kilowatt plant can do wonderful work. The same picture, the components, 772 PV modules with 8 numbers of string inverters. So the same plan provides this much of environmental impact. So this is the way that how it is becoming carbon neutral. Helioscope, I find it is very useful for your resource assessment and all feasibility studies. Basically, feasibility, you can do 3D blocks on it. It is a kind of building things on your Google map itself. So Helioscope is a very interesting software. You can do simultaneously project many PV panels on it. See some projections on Helioscope like different module arrays provided. It has got some interesting output of your loss happening. Your wiring losses, shading losses, reflection, soiling, gradients, all these things will be there. See, why we do this for monitoring? I'll give you some example of when I was doing when we were managing the projects, we did the design, the total engineering solutions for a 25 megawatt when I was a consultant with the PB. So we did the 25 megawatt project in Charanka. Charanka, the first solar park in India, in Charanka village in Gujarat. It was a 25 megawatt plant. So there you can see the results of the plant. We have plotted, this is for 6 months. 6 months for each day, there was a generation target. Using PVSys, we predicted it. And we achieved a little bit more. You can see it was a kind of a project with the thin film. It was an amorphous silicon, crystalline silicon tandem junction plant, a thin film plant, first of its kind during that time in 2011. Later resulted very good because mostly thin film plants will perform more in very high ambient temperature because of its temperature coefficient property, better than the crystalline silicon PV modules. See, you can see the prediction follows the prediction always follows the that you can see from here. This is the predicted generation. Yeah, you have the generation target here. This actually I have done using PVSys before the plant, before starting over the commissioning for installing the plant. And this is the plant. This is actually the net exportable power coming up. It's more than the prediction. And this is actually the average global solar radiation. So it follows that. See, my finding from this is because of the prediction, it became more because of we had a seasonal tilt arrangement, the prediction done without any seasonal tilt prediction. So this is the seasonal tilt means we had from October to February a kind of tilt which is more to capture maximum winter radiation. And during summer, the tilt became a little bit less. So if you look at Gujarat, 22 degrees is the total latitude. We added 15 degrees extra during the period of October to February. So the workers will clamp into more tilt. And during the summer season from February to September, the clamp will be something like with minus 15 of 20 to minus 15 around. Yeah, that will be the tilt for the summer season. So we got a little bit more generalization. That's why this prediction came. Because a very good achievement in terms of the plant. So I'm just telling that. So this is very much required for assessing your design, assessing your performance of the plant, getting your PR verified with the predictor on. And I'm just concluding. I've taken more than the time allocated. A lot of projects are there now. The trend is IoT-based data monitoring than the embedded systems generally used conventionally with now. And a lot of distributed generation is connected with this kind of data connection arrangement. You need to do a good feasibility as well when you go for installing. That is not a practice here in Kerala or India. So I would suggest that we should have a pool of data coming up in our central station. That the same has been accomplished at KCB recently. It's a very good achievement actually. Like they have put up all these solar power plants into a central data monitoring system so that they can centrally monitor it. So so it's very important. And even I would suggest that distributed generation should be monitored at your fingertip using your Android So I always insisted to put this kind of resource assessment for any plan above 2 kilowatt peak. But commercially, we generally insist as a hard rule about 10 kilowatts. But better that you have that resource assessment done. And it's good for RE microgrids. I already told you about the Tanzanian situation. In Kerala also, around a lot of remote communities are where you can just get an idea of what actually happening there in this microgrids using your remote assessment. And see, this blockchain applications and all, when you use solar energy for distributed generation, you have a specific entity for each individual or each consumer. So each consumer is becoming a prosumer. So the individual identity has to be there. And how much energy they are selling to the nearby community, selling to the grid or selling to the neighbor is very important. So there the resource assessment is very important, how much resource they are getting. So what exactly the prediction, they can forecast this. The forecasting is very important in a blockchain kind of arrangement because the precision was something like 8%. I think I remember some conference I attended in 2003, the forecasting precision was 8%. Now the precision has something around 2%. That much of accuracy is there. So you can predict what exactly coming up from sun. Accordingly, you can design your trade. You can trade among you. So it's very important in blockchain as well. So with this, I conclude, and I think I taken a little bit more than my allocated time. Thank you, IEEE Consultants Network Kerala chapter, Kerala Affinity Group, and especially our beloved BKD sir for inspiring me and giving me this opportunity to speak, to share my thoughts and to share my experiences. We will have a nice discussion. Thank you again. Thank you, Bhai.
Okay, thank you, Gobi. Before we leave the floor for a few minutes discussion on the various technical aspects, comparisons and all that thing, I want to raise one general question. That is renewable energy propagation, or what you call its spread, is actually expected, and internationally it is actually fairly well on the assigned path. As for India is concerned, even though we have actually raised the targets, even the earlier target which our Prime Minister set initially of 100 GW of solar is yet not realizable as we expect. I think it is only at 40% target now. And we have actually 1.5 years more to complete. So I don't think we are going to reach there. And I find two problems associated with this. One thing, unlike in China and all, for example, we were mentioning about Jiangsu province. Jiangsu province, the advantage is that 60% of world's solar panel and inverter manufacture takes place in China, of which 60% of China's output is coming from that single province, Jiangsu. So, and they have been actually doing projects at such enormous speed that they had even a problem in 2015, especially when they did the wind energy campaign. 20,000 megawatts of wind energy during a particular season was actually forbidden from entering the grid because nationally they could not actually use all that power during that season. So this is a problem. So that is the development there. My point is not that. What I find is, if we really want to progress in solar utilization, two things are required. One, investment should actually increase substantially. Number two, any renewable energy project which we expect will be successful in India also is based on how much employment it can actually create, without which investment will not come. Apart from all the technicalities, this is a reality which should be the only what we call the support sticks for its growth. If it is to walk, we should have these two things. And luckily for solar, the advantage is that all the new employment potential that we see are going to be distributed throughout the country and throughout urban areas and rural areas. So it is actually a kind of a very useful positive feature. But if you really want to exploit all the employment potential there, we should be able to use these things in certain areas, and some of our electrical consultants, instrumentation consultants, and power electronic consultants, they will have to actually set sail specifically to attract or take consultancy project in this area. They will have to have a kind of shift. So what I really want to know from your own long experience of consultancy in this area, renewable energy, for about 20 years or so, I will just ask you, for our consultants who have been previously attending to some of the consultancy jobs in various other areas, which are the areas they should pick? And similarly, fresh graduates who wants to find employment by themselves, that is enterprises to start, which are the areas you will actually give preference at this stage when we are actually taking up? This is my point. Ultimately, in these two areas, what are the areas we should actually focus more, so that the consultants under our umbrella will reorient their priorities and emphasize more on the technologies, their use and comparisons that you have actually given a very, very comprehensive comparative picture. So this is my question. If you can briefly answer that, we can actually go to for a few minutes on other technical aspects.
Thank you, sir. Thank you for the question and the insights. Actually, as well pointed out, sir, I do remember, as you said in the background, I visited Beijing actually in 2010, part of my Swedish program. It was an international program. So when I was in Beijing in 2010, not part of this project, that I later went in 2011 or 12, I remember. So 10, what I see in Beijing was no wind energy side, they were not very below. So the major issue was the infrastructure, power infrastructure. And after 2000, when I was visiting for the Shanghai or my Jiangsu province project of due diligence, I could see that the explosive growth on the infrastructure side of bringing the grid from the eastern side to the western side, where more population is there. So, of course, their expansion on the manufacturing side, the Jiangsu province is seen an explosion. We were given some due diligence assignments even on the rooftop of some PV module generation factories. We didn't know that were factories. We were just doing due diligence in some factory rooftop. Then later only I understood that beneath there is a factory. So it was so wonderful. So what sir was pointing out was very important. The power infrastructure is very important for any country to move more into solar or wind. Wind definitely you need. That is a thing that we have to learn from China, because if you look at the total capacity installed globally, both in wind energy and solar energy, the exponential growth has happened in China, and that is in tandem with what they have done in the grid infrastructure. So the same pace actually we should build in India as well, for reaching, as Sir was pointing out, to reach 100 gigawatt by 2022. We are actually trailing around 40% of, or less than that, is the current. It's like just about 36 gigawatt. So 100 gigawatt, it's around 40% gigawatt is only achieved. So we need an increase. Of course, COVID has made a lot of impact on it. The COVID has delayed a lot of commissioning. Still, we can do wonderful things if we plan very judiciously. We have a lot of area where you can have utility scale power plants. We have a lot of technocrats available. And for areas where you don't have the utility, you can have rooftops. You can just judiciously take a decision, political decisions. And coming to what the important points I was pointing out regarding the fresh graduates, the areas to be taken up on renewable energy consultancy. My experience is actually, when I joined this PB consultancy in 2010, later part of 2010, 11, we needed a lot of electrical graduates. Actually, we were searching for somebody who knows the basics of power systems, actually, to train them, to equip them to do some of our assignments as site engineers, site managers, as guys who design systems, guys who kind of PV system or WASP design and all. So my advice to the young graduates that you cream up your graduation with some of your good certifications from reputed institutions. You add a flavor to your graduation, so that you will get more acquainted with the industry. And nevertheless, to say that you should have a good background on your electrical engineering or mechanical engineering, whatever may be your field of study. At the same time, for example, I had teams, some 10 people were working under me in wind energy. So they were doing kind of power curve measurements on different areas for wind machines. This power curve measurements will be something like a small wind turbine, actual wind turbine, and parallel to that you will have a wind mast. So doing a power curve comparison. So just kind of checking the actual data sheets with the measure on. So we needed power curve measurement that guys with a very strong background on wind energy doing this kind of power curve measurements. We needed a lot of engineers on doing studies on wind resource assessment. I'm looking at wind. Even in Kerala, we have a tremendous wind resource, actually. We are around the 5th or 6th in the country, but we cannot tap that much of energy just because of we don't have the bankable wind data. That is another subject I cannot discuss here.
This you wind up fast so that we will take up one or two other questions.
Yeah. So I would like to recommend that all these areas, actually, in solar, we need engineers who design the projects using softwares. We need drafters who do drafting work to provide your PV modules in arrays. We need engineers who in the sites do the site installation, manage it, and we need site managers. Of course, consultants. Lot of consultants in all areas to do due diligence, to see that whether this solar power plant or rooftop power plant really work or not. So a lot of areas of expertise needed. My request to all the young engineers is that you cream up your graduation with some sort of international trainings you are getting now freely, or a little bit of paid assignments. But that is worth. Yes, sir. I think
Okay.
we hope to answer it.
Yeah. Gideon, any questions in the chat box, or we will ask people to unmute and ask their questions, brief questions, and Ajit will actually make brief replies.
We don't have any questions right now in the chat box. Participants, if you have any doubts, you can ask right now. Please share your doubts.
I find CM Varghese over there, he has been working in power electronics area and renewables interface for a long time. So could you please make some observation?
Sir, in fact, I joined very late. I had another meeting.
Oh.
So on the consultancy, I feel there is a lot, because solar is still in the very interaction level is very low in Kerala. So it has to penetrate much more, maybe in next 2 years, because Kerala had a target of almost 1,500 megawatt, because our total target is 1870 megawatt. Out of that, we are reached around 300 something only. So there is a big target. For that, as Ajit was telling, you need a lot of designers, a lot of engineers, definitely a lot of consultants who will be able to assess the site, assess the requirements, and support design of the systems. So electrical engineers, specifically electrical and mechanical engineers who are exposed to this field, definitely there is a good opportunity. But organizations like UNERT has to come forward to spell out what exactly they have to do and how many numbers such people can work for these projects, because there is a 1,500 megawatt means quite a lot. Yeah. So this is my observation on this.
Well taken, sir. Well taken. Actually, it's a great suggestion, sir. Actually, we need to mold engineers into this kind of groups, making designers, guys who do due diligence or inspections, doing feasibility. So getting access to the sites, as Varghese sir was mentioning, getting access to the site and molding it to or framing up that requirement to a project is very important. So that's very, I think UNERT can do a lot on this. Actually, we already arrived with the specifications for projects, especially on rooftop plants, off-grid and on-grid. I was fortunate to be involved in it. So the important thing is how we can frame up these kind of solutions with all these engineering inputs. That is actually lacking. We don't need kind of Sussman solutions or kind of photostat solutions. You cannot replace a 5 kilowatt plant everywhere. So you need to do what is the design of that particular site. I think Varghese sir can agree on that, because site specific it is very important. So if you look at if you have a tilted rooftop, you have a ground, or if you have a rooftop which is facing west. So even you can do it if your roof is facing west or east or south.
True, Gobi. I'll mention that this is exactly the importance of the resource assessment task. That is actually very important for beginners like Kerala or even India as a whole. But for 2 or 3 states, all other states are beginners. So there, this resource assessment, getting trained for that and getting the quickly what are all the essential points required and the real tools required. Otherwise, what happens is if you go on using these softwares, you will finally go into a mechanical action. Because I remember 15 years back or 20 years back, I was using Red Screen for small hydro designs and small hydro power assessment comparisons, etc. At that time, that was actually a very novel thing for this one. But now they have actually entered into this area. As you have said, it is actually a very good, powerful software. But many a time, the users actually forget the ground realities and they just get guided by the some of the points or stages or some of the factors set into these things. In one master's thesis evaluation, I found one student actually using a Japanese software and using the tilt, which is totally irrelevant for Kerala or India. So that is the extent to which some of these softwares can stray the users. So this is where we should actually prepare these tools in such a way that new entrants should be able to use them specifically for our area. Otherwise, we won't pick up speed. And this is where I think ANERT should, and also many other consultants and designers from Kerala as well as from other parts of India, some companies which are old, some companies which are new, they all can actually have a, I think either the central government SACE or people should definitely coordinate this and guide consultancy into it. Then one other mistake is many experts who have actually come up with efforts and time, they are currently being utilized by many countries in the Far East and the Pacific Islands. Because there is dire necessity for engineers who know what is ABC of solar alone. Because this is very important for them. They cannot think of large plants and all. Their microgrids, all these things. But this, I'm not saying that we should actually go into those markets and make a survival. But more than that, we have to have all these talented immediately employed here. And with that experience, some of the experienced people, let them go and help them. And new people coming will be able to take over. That is one thing. And you were actually in the beginning mentioning about REN 21 report. This year's report was actually published on 15th of June. I was actually there at the opening or launching function. It has come out wonderfully well and far better than previous years because there are very powerful analysis for various regions, including India and other parts. So I think this has only just touched. If there are no other questions, I will just conclude by saying that this has actually aroused the interest of at least those who have attended. And recently there has been a problem that even within IEEE as well as outside IEEE, there are large number of online meetings, and our listeners or our members are very much divided into many of these committee meetings or many of these lectures and many of these other kinds of programs related with this. From next time onwards, we will actually try to see whether the interested people from other, it need not be limited to consultant network alone, all other areas of IEEE engineers as well as non-IEEE engineers who are interested. I think we should actually give publicity to as many people as possible, and we will try to get probably a bigger gathering. And maybe we can also give a gist of the talk in the beginning so that people will be well prepared for kind of framing their questions. Because, for example, in this talk itself, there has been a vast array of subjects, each one of importance to consulting itself and also for solar energy and renewable energy in particular. But many of the interested speakers, listeners, had they got some idea, of course it is our own mistake, they would have been probably better equipped to get maximum material from the speaker. Anyhow, we will try to correct ourselves for the next meeting. And one announcement I want to say is next lecture will be by a German expert who is an international inventor in biogas technology, engineer Walter Danner. He has so many international awards for his innovative biogas things, and I especially invited him. The details and the summary I will actually try to pass on sufficiently early so that you all will be able to take advantage of that. Generally, it is very difficult to get him. He is an internationally very busy consultant. Just because we were actually together in certain assignments of UN, and we have become a friendship. So I have just managed to get him. So we will give sufficient publicity and let us have a bigger gathering for the next one. So can you have a one sentence vote of thanks, Gideon, and we will close it.
Yes. On behalf of IEEE Consultant Network Affinity Group, Kerala section, I thank the speaker, Engineer Ajit Gobi sir, for sharing his valuable knowledge and experiences in the field of solar energy industry. And I'm sure that we have all gained some information that are not readily available in other sources. Such information is available because of his vast experience in this field. And I believe that all our participants have benefited from this. And I also thank our chairperson, Professor VKD sir, for leading this initiative for conducting this webinar. And I also thank all the participants for making this event a success. Thank you very much.
Okay, thank you. Meeting is over.
Okay.
Thank you very much for that.